All right, folks, it's Bass Action back in action here. On this page of notes, we're going to dive into converting back and forth between our logarithmic and our exponential forms and the other way around. And then we're also going to look at our domain. So let's start with the domain, and then we'll move into converting back and forth. So on the previous page, when we were looking at our graphs, specifically our logarithm graph, we noticed that the logarithm had a restricted domain. It's specifically going to be restricted on what we would call the argument. So what we know is that this argument here has to always remain both positive and non-zero. So thinking back to what we were doing with our radicals or even roots earlier in the year, we're going to first find where it equals 0 because that creates our boundary between positive and negative. So we can make our number line here, and we can first just identify where is this argument going to become 0, and it's going to become 0 at a -3. I'm going to automatically give that an open circle since I can't evaluate the log at 0. Thinking of that graph, that's where that vertical asymptote occurs. And then we just need to test on either side of this, which side will give us positive arguments, which side will give us negative arguments. On the left-hand side in this case, for example, if we did -4, we would get a negative argument, so that whole side gets eliminated. The right-hand side will give us positives. You could test it with a -2 or a 0, but that one's going to work. So we can write our domain most easily in our interval notation. So that would be our domain for that first function. Now the second function that I've given you here is certainly more complicated. It has a fraction in here. We can think of this as an implied inequality. What we want to do is we want to look at both that numerator and the denominator. So if I look first at my numerator, what I'm going to notice is that at x equals -3, we would have a log base 5 of 0 because it would make that numerator 0. And if I look in my denominator, I notice that I would have an x equals 4. And what I would notice here is that the denominator would become 0, which of course is also not possible. So when we set this up on our number line, we need to put both of these x values on the number line. So I'm going to put my -3. That's going to be open because it would cause the log itself to evaluate at 0. And I'm going to put my 4 also as an open circle because that would make the denominator, the fraction itself, to become undefined. At this point, what we need to do is we need to test each of our intervals to determine where the argument itself stays positive. So this is similar to what we did with our rational functions. So let's say I pick -4. I'm working with this far left interval. If I put a -4 into the numerator, I'm going to get a negative value. If I put a -4 into the denominator, I'm going to get a positive value. So my negative over my positive is going to be negative, so that entire interval would get rejected. Next, I'm going to look in this central interval. I'm going to choose 0. That's going to be my easiest one to work with. And if I put a 0 in the numerator, I get a positive. If I put a 0 in the denominator, I get a positive. Of course, positive over positive is positive, so this interval works. Continuing on, if I go on the far right and I pick a 5, I'm going to get a positive in the numerator. I'm going to get a negative in the denominator. Just like on the far left, that gives me negative, so that whole interval gets rejected. So my final answer would be this interval here in the center. It's not always going to be the center. We always have to test. So our final answer would be written as -3 to +4, non-inclusive on either end. All right, so that's a little practice with our domain. We'll certainly do more with that in class. Now let's work with moving back and forth. A couple reminders here that from your Algebra 2 classes, that the base of a log will become the base of an exponential. And the big thing that we want to be thinking about throughout this entire unit as we're working with logs and exponentials is they are simply inverses of each other. We just really want to get our head around that. So you've noticed that I've given you a line here to write your answer on, because this is where I notice students tend to struggle in terms of writing their answers. Things tend to float and sizes get thrown off, so we're going to practice actually writing it on our line. If we wanted to convert this logarithm here to its exponential form, we can draw on this convenient circle. We're going to start with our pencil on the base of the log. So I'm going to start with my pencil there, and I'm going to draw this little circle that goes under the equal sign to the other side, and then it's going to come back around. What that's going to allow me to do is to remember that this base of the log will become the base of my exponential. So I'm going to put that right on my number line, or right on my answer blank, and I would think of as like a normal font size. And then my exponent is whatever was on this other side of the equation, so it's going to become 3 to the y, and then equals as I come back around, and it equals whatever the argument of the log was. So these two are the exact same thing written in their opposite forms. Now, this rewriting notation is particularly useful when we actually want to find the inverse of a logarithm, because the inverse of my logarithm will be an exponential. So I need to rewrite this in its exponential form. So the first thing that I'm going to do, just thinking about inverses, is of course write this with y instead of the f of x. So I have y equals -4 plus my log base 15 of 3x. Then I'm going to switch my x and y's. Always remember that's our next step. So -4 plus log base 15 of 3y now. And now I'm going to start solving for y. So what I want to be thinking about is I need to isolate this logarithm here first before I can actually do any converting. So I'm going to add that 4 to the other side. So I'm going to have my x plus my 4 equals my log base 15 of 3y. Now that the logarithm is isolated, I can start converting this to its exponential form. So the base of my log will become the base of an exponential. Parentheses are nice here, and then it'll come back around. So when I write this, I'll have 15 to the x plus 4 equals 3y. Now, I can divide both sides here by 3. The risk of that is sometimes students want to reduce these two values here, which I cannot because the 15 has an exponent on it. So a much more helpful notation for you on this would be to pull out that 1/3 and write it as a coefficient. So 1/3 and then 15 to the x plus 4. So this would be our best way of writing that inverse. Let's do one more here. We're going to convert the other direction. So we're going to go from our exponentials to our logarithm. So just a reminder that the base of our exponential will become the base of our logarithm. So a little bit more practice. Here's my exponential. So I'm going to do a similar circle. I can draw those in again. So the base of the exponential will become the base of a log. So this is going to be log, think normal font size. The base of that exponential becomes a small subscript. So log base 1.2 of the m equals the 3. So when you look at this on the line, the only thing that's small is the subscript for the base of the log. Everything else should have the same, think, font size. We can do one more here. Thinking that circle first. So this is going to become a log base e of 9 equals b. And then just a little bit of review from our lesson last time that this logarithm here, this log base e can also be written as a natural log. So I could write this same answer as the natural log of 9 equals b. And that's probably the more common form that you'll see. All right, so let's find the inverse of an exponential. So first step, again, just reviewing, let's rewrite this with a y. So I have y, and then I have 15 times 3 to the x minus 2, switch my x and y, and then we want to start solving and we need for the exponential, so we need to isolate this piece first. So we're going to divide both sides by that 15. So I'll have x over 15, 3 to the y minus 2. Now I can switch to my logarithm. So I always like writing those little arrows in. So I'll end up with log base 3 of this goofy looking x over 15 equals y minus 2. And now I just have to add that 2 to the other side. So I'll end up with my 2 plus log base 3 of x over 15. And that would be our inverse. And that's all we've got, and we'll do a little bit more practicing on the next page of a few other skills and practice this more in class.